Okay, so here is our pre-recorded video of systems of equations. So today's May 27th, and I am gonna just record this video because I can't seem to go live right now. So yeah, sorry about that, but I think that this is gonna be just fine. So my goal is to take this all just in one take. I really don't wanna be, hunkering down and doing a bunch of editing because editing can take a tremendous amount of time. So I'm just gonna go in one shot. So it might not be the smoothest video, but I mean, just pretend it's live, and I'll say, "Oh yeah, hi, thanks for logging in." I might pretend that we're actually all here. So anyway, yeah. So let's get started. So we're gonna talk about systems of equations, and before I actually just jump into what our textbook says systems of equations are, I'd like to give sort of my own introduction to the topic, and I want to tell you how I understand what systems of equations are. So systems of equations, well, we're going to take a look at kind of the etymology of this and what these words mean. So systems means that there are many parts, right? So any kind of like a computer system is a computer that has many parts to it, and that's kind of what a system is, right? It's something that has components, and all those components work together. And equations, well, those are going to be, in our case, we are going to look at either linear equations, so that's going to be one type of system that we'll look at, and we will also look at systems of quadratic equations. And sometimes, in fact, kind of what we're aiming, excuse me, I've got the hiccups. What we're aiming for is to look at a combination of these. So our end goal is to look at systems of equations where some of the equations are linear and some of them are quadratic. So we're going to look at a combo of these two. So what the heck is a system? I mean, I've told you that there's many parts and there's equations. So really what it boils down to, so all of this kind of boiled down into one thing, is that we have many equations. Okay, we have many equations, and we're looking for one solution, one or more. And then what we'll actually see is in some cases we will have none, so or none solution. Okay, so what the heck does that mean? Like, we've got a lot of equations, we're looking for a solution. What does that mean? Well, let me just jump right into an example, and we'll see where that example takes us. So I'm going to say we're going to solve the following system of linear equations. Okay, so what does that mean? So equations, because it is plural, that's very important because we're looking at several linear equations. And I'm just going to come up with kind of a random set of linear equations, and I'll see where that takes us. So let's try, how about y equals, I don't know, 2x plus 1. And then maybe we'll do y is equal to negative 1/2 x, I don't know, minus 2. Something like that, something straightforward. So we're looking for a solution to this system of linear equations. So why don't we start off by graphing these two linear equations and see what we get. So I'm going to make my x-axis, sorry, that was my y-axis. Now I'm going to make my x-axis. So here's my x-axis, my y-axis. Okay, and so I'm going to start off with the first one, y equals 2x plus 1. So lucky for me, it is in slope-intercept form. I'm just trying to make it as easy for us as possible just to hit the ground running. So I'm not going to make you convert these into different forms quite yet. But as we progress through this topic, we are going to be looking at some equations that are actually a little bit challenging to graph. Anyway, that's the first one. So let me just write down that this is y equals 2x plus 1. And then maybe what I'll do is I'll turn this one pink. So I'll change the color to pink, and then I'll use a pink marker over here to graph y equals negative 1/2 x minus 2. So here is that point right there. So there's the y-intercept. And my slope is -1/2. So I go over 1, down 1/2, over 1, down 1/2, over 1, down 1/2, etc. And then I go over here, over here, over here, over here, etc. Okay, so this might, come to think of it, this is probably not actually the best example in the world to have chosen, but I think it'll give you an idea of what we're aiming for. So there's our other graph here, and this one is y equals -1/2 x minus 2. And it's going to bug me because these are actually different shades of pink. I know that doesn't really matter, but I would like them. I think this one's actually a purple-ish. Anyway, so what do I mean by finding a solution to this system of linear equations? Well, first of all, let me get this dot in the right place. There we go. So a solution to this is going to be where these two graphs intersect. So this point right here is our solution. Okay, now because it is a point on the Cartesian plane, right? It's a point on our graph. It's going to have an x value and a y value. Let's call that x1, y1. So we don't know what these values are, but that's kind of the purpose of this, this topic, is we're going to look at different strategies. We're going to look at different strategies of solving these systems of equations. Now, this is a system of linear equations, so it's fairly straightforward. However, some of the ones that we'll look at later on become quite a bit more complex. So the first thing that we're going to do is sort of look at the graphical methods of solving these systems. So we're going to graph these systems of linear equations, and we are going to observe their solutions. So this solution right here, by the way, it's kind of hard to say exactly where this x1, y1 lies, right? I mean, I know that, you know, x1, it kind of looks like -1.1. So I'm going to say like -1.1 or something close to that, maybe 1.2 or 1.25, right? I'm looking at how far does this point go from the origin here, right? So that would be x1, and then y1 would be how far down I went. So that also looks like it's about this is supposed to say -1.25, and y1 is approximately equal to -1.25 as well. Let me just write that a little more clearly. -1.25. Okay, so they both look like they're at about -1.25, but it's hard to say because we're just looking and we're just eyeballing it. So what we're going to look at in the next coming classes is we're going to look at methods for finding precise values of these intersection points, basically using algebra and kind of leaving the graphing out of it. However, it is really important to understand how the graphing plays into it, but for now, we're just going to sort of use the graphing as sort of an eyeballing tool, and then when we develop a better understanding of how the graphing of these systems works, then we'll jump into the algebra and see where the algebra takes us, because the algebra is going to help us calculate these values exactly. So that's all I wanted to show you. I want to keep this video nice and short because it is hard to make these videos without any kind of feedback or people talking or anything like that. So I'm gonna end it here. I won't have an exit slip today. I don't think it makes sense to have an exit slip on a video that's not live. So we'll kind of leave it at that for today. Hopefully tomorrow my microphone will work and everything will be back to normal. Well, normal-ish, whatever normal means these days. Anyway, I hope you guys are doing okay. I miss you, and I will talk to you tomorrow regardless of whether or not it'll be live or not live. There will be a video for you tomorrow. Bye-bye.